Good morning, everybody. The question you're all asking yourself is, how do I get started in cloud computing? This is a common question. I've probably had about 45 people in the last month. That's more than one person a day ask me, well, how do I get started? Yeah, it's actually a pretty valid question. I kind of assume in my videos that you're already in IT, that you're already, working with some kind of system on premises. This is a typical step towards cloud that we take. You work at an IT company, you work in an IT department, you work somehow in an IT environment, but a lot of my viewers seem to be students who are studying computer science, who are studying programming, developing, yeah, it's a valid question. How do I get into cloud? What I would say is that when we talk about cloud, there's a big advantage from the old traditional IT environment, whereas everything is publicly documented, right? That's the real big advantage. If you're a beginner, if you're just starting out, then it's super easy to get into these solutions, to start learning about these solutions, to start designing these solutions, because they are all publicly documented. Now, I'm kind of assuming that you have some kind of affinity to technology, that you have some affinity to computing. Otherwise, why would you watch my channel, right? But if you don't, if you're a pure beginner, if you don't really know anything about computers, well, maybe you're into gaming and you know how to build your own computer, right? This is the level of entry that you have to sort of have, right? For me personally, my level of entry was my dad worked at a company that did supply computers and things like that, and he brought home a PC just to test out, just to see what it is, a novelty thing, right? That was in the 80s, right? And I wasn't old enough to understand how to use that thing. It was just amazing that you could open up, a sort of desktop that was sort of graphical. This was Windows 2.0, right? So we're talking about pre-Windows 3, which is most people, which is what most people are familiar with. And it had these kind of graphical windows, and you could open up a program that looked like paint, and it had a schematic of a space shuttle. And he worked with printers and needed to test some printers out, and then he printed that schematic of that space shuttle for me, and that was one of my prized possessions. But of course later we got a home PC. Well, let me back up a little bit. Before that, for example, we used to have a Commodore 64. We used to have a computer, but to me that was just a game station, a game machine. I was impressed by the PC's ability to not only just have that graphical user interface, which was unprecedented at that time. The other thing I was impressed with was the actual hardware, because you could open it up, you could pull stuff out, you could plug stuff in, right? And this is where I basically got started, was my early teens, basically taking the computer apart and seeing how things work in it. Like literally just no YouTube, there wasn't any YouTube back then, literally just exploring, just unplugging the computer, opening it up, seeing what's inside, seeing what those things are. And then I sort of read that we had these magazines back then, these kinds of PC magazines, and I sort of read in a PC magazine about graphics cards and how graphics cards can change gaming. And then I was like, okay, we got to figure out what the graphics card is and how it fits into my ISA slot. And yes, I'm talking about the ISA bus, the old long black port that you plugged in ISA cards into, and you'd have like 64 color card, and they were you know, showing us a 64 color card, and it was like, wow, right? Amazing stuff. I mean, I had monochrome. That was way more than anyone ever needed, basically, back then, for everything, for all the games. And I had a friend who had a 16 color card. These are not 16-bit or 64-bit. We're talking about 16 actual colors, right? There's a graphical adapter that had 16 colors. Yeah, I might be remembering the 64 wrong. It might have been a 256 color card. So it was amazing as far as the, you know, actual ability to show you colors was. But of course, those things were expensive. Color screens were expensive. And yeah, we never got one for our home. So that's how I started with computers, and I learned how to navigate the DOS operating system and Windows pretty soon. I learned how to do some basic command line interaction, how to create a batch file, right? .bat would be a batch file in DOS. What would now be a command line file, and I learned to automate things a little bit. Having that experience actually got me a job when I was 15 or 16. Yeah, basically the 2 summers, when I was 15 and the summer when I was 16. I got a job at a computer company. They were looking for, like, you know, summer student job work types, where when you come and fill in for other people. And I went into the sort of assembly of computers. Back then you would do assembly, right, of computers. You wouldn't go to a store, you'd go to this company that would assemble computers for you, right? So what I did there was, we had computers, you'd unpack them, you'd power it on, you'd put a little sticker on it that it was tested, you'd put like a declaration, what the components are, what the country of origin is, and things like that, right? All of this was done like manually. You'd pop in some cards, you'd put a network card in, you'd put a graphics card in, whatever was needed, right? And that was a really good job. That was a well-paying sort of summer kind of internship style work. It wasn't a real job, right? It was just summer work. And then later, my enthusiasm, you know, went into 2 directions. Yes, of course, you know, games in one direction, where you like playing games. Everybody likes playing games. I still play a game or 2 here, even at my age, right? But the other direction where my enthusiasm went in was just doing the old, you know, hardware stuff. Like, for example, I found about overclocking, and I started to try and overclock my CPU. Back then you had unlocked multipliers, so you could do crazy stuff with CPUs. You had to have pretty powerful cooling. I never got into water cooling back then. That was not really a thing yet. It was, but it wasn't. It was pretty dangerous, because you know, water and electricity don't really mix well. So I never really got into too deep into that. But during that time I did learn a lot more about CPUs, a lot more about memory speeds, CPU speeds, the buses in your environment. Back then the PCI bus was the new thing. 32 bits on a bus. Wow, boom, blows your mind, right? And the PCI bus was like something really special, and was like sort of game changing at that point. Then there was that special port in the PCI. I don't really remember what it was called, but it was a specific bus where you plug your graphics card in. So that was a new thing then. And then, you know, slowly technologies started advancing, USB and all that came along, and everything that you have in your computer now basically started in with the PCI bus, right? Because it's a standardized architecture. It's what PCI Express is built on, where essentially a PCI lane is an extension, is like a complete PCI bus slot, so any can then plug them together. You can get up to 16 lanes together and have 16 times the throughput for your platform. No, I'm simplifying here. There's way more to it than that. What I wanted to say was, I got interested in the hardware, and that sort of gave me an opportunity to get an open position at a service center. There was an IBM service center in our local area, and I was able to get a position there as a sort of technician. The big benefit of that one was they would offer free training, basically almost as much free training as you wanted, right? Because it didn't cost them anything. You'd go to the IBM training center, you'd get trained by IBM instructors, you'd sit in a class that IBM business partners would sit in. So the cost of sending you there to that training was essentially zero for them. So that was a big benefit. I got to really learn about technology then, as far as, you know, not just how things are connected, but also how to fix those things. Well, the most fixing that we did was actually replacing components, right? We didn't fix a lot of things. We would recover drives, we would recover data, we would replace some components, like for example, we would replace some capacitors on some boards, but we wouldn't go down to board level repair. The capacitors were basically because there was a really bad batch of capacitors circulating at that time, so there was some replacement of those. But otherwise, I didn't really get into soldering. I didn't get into, or as Louis Rossmann would say, soldering. I didn't really get into real component repair. But at that point, my focus was more like troubleshooting, right? What is wrong here? And when there was an issue that people couldn't troubleshoot, they would bring it to me and I would troubleshoot it. I would, you know, spend 2 days if I have to fix that thing. That was something that was intriguing to me, troubleshooting computers, troubleshooting the platform. And yeah, that's definitely something that led me into my path towards servers and server maintenance, right? And the servers and server maintenance meant, okay, now you basically have a much more sought after portfolio if you stop fixing laptops and PCs and you go into servers. But what are servers? Well, they're basically just big PCs, right? They had some different technologies. They had SCSI drives instead of IDE back then, right? Now it's all the same thing. They had some, you know, more powerful stuff like fast Ethernet, and fast Ethernet was 100 megabits, right? Back then, fast Ethernet instead of a normal Ethernet card. Yeah, working for IBM, Token Ring was still a thing back then. If anybody remembers that, thumbs up for Token Ring. yeah, then later, of course, I got into storage systems, networking a little bit. Storage systems, fiber channel, small, you know, fiber connected disk shelves, or even small controller based fiber platforms, and then basic networking, which was back then, you know, plugging a card into a switch and then configuring a switch with some VLANs, maybe some layer 3 routing at best after that. So this is over this, you know, this hardware path is like starts in about, you know, the 90s, when I was doing these summer work things, and then early 2000s when I get into servers and things like that, right? So we're talking about years of experience, years of gaining experience, years of working on something. This is not going to happen overnight. Well, I knew this was not going to happen overnight. Now, when you do server maintenance, you of course have to get into the operating system also. So the biggest sort of leap in my career was going from the Windows operating system to Linux at that point. Why would I say that was a leap in my career? Well, because knowing Linux and understanding Linux, and actually I got Red Hat certified back then. I was Red Hat certified on Red Hat Enterprise Linux 3, right? That's a long time ago. Yeah, passing my RACE was a game changer for me in terms of just the ability to get work, just the ability to get different types of get into different types of positions. So I never sort of became like a core Linux engineer. I was really interested in virtualization, and virtualization for me was like, all right, that's the right way to go at that point, even though everybody was pretty much laughing at it. Early 2000s, I remember back in, I'm gonna say 2004-ish, 2004, 2005 maybe, when VMware was on vSphere 2.5, and they were sort of announcing that, oh yeah, there's gonna be a big change coming in. It's gonna be vSphere version 3. It's gonna be all kinds of cool stuff like integration into hardware, and it's gonna be graphical and all kinds of cool stuff. A lot of people were like, what's the point, right? What's the point of virtualization? Because, you know, you can run 2 servers on 1 physical box, woohoo, at that point, right? But, you know, they were proven wrong. Virtualization for me naturally led to the evolution of going into cloud, right? And my sort of path into cloud was actually building solutions that you could call sort of infrastructure as a service, semi-automated infrastructure as a service, where we would we had a platform that we built on VMware. We had you know, cluster servers. I talked about this in one of my previous videos. That's the same platform that I'm talking about. And the self-service part of it was, yeah, we gave you access to vCenter, and you could, you know, start and stop your instances. That's basically all you had. You weren't able to, there was no ability to self-provision. There was no API to talk to. There was no automation, auto scaling. There was nothing like that, right? And at the same time, this is like 2010, at the same time, you'd see like Amazon, you know, starting to introduce things like auto scaling and having metrics and having hourly billing and things like that. So as you can imagine, you know, that was a small company, and it was a niche market that they were covering. As you can imagine, that didn't last. So my next step was actually joining a company that was working on a project that was building cloud solutions through a European initiative, Eurocloud. It's basically the European Union had decided back in 2008, 2009, something like that, to actually start building solutions, cloud solutions in Europe, because there are no real providers in Europe. There's no, you know, tier 1 providers. There's, well, there's a few, but they're tiny. And their initiative is like, let's spend a bunch of money and let's figure out how to build these solutions, how to stimulate this process. Now, of course, this process was heavily reliant on you know, just admin work and reporting and bureaucracy, basically, right? It was a project that where you, if you satisfied the result of the bureaucracy, you'd get the money, regardless of whether that product that you built worked or not. So yeah, that was something. Okay, I got this garbage truck coming, so I'm gonna pause a little bit, and there goes the garbage truck. Anyway, I'm actually going to talk more about that. Yeah, I wanted to talk about how to get into cloud computing, and I sort of gave you my bio here in a very condensed format, where I showed you all the steps I had to go through to get into cloud. Now, what I'm going to say is, you don't need to take that path. You don't. This is not a best case scenario, best path, whatever. Now, there's a few lessons to be learned from my experience going into cloud. The first thing, cloud 20 years ago and cloud today are two different things, right? 20 years ago, it didn't really exist. You had some, you know, service offerings, but nothing self-provision and things like that. 10 years ago, yeah, 10 years ago, we're looking at cloud being an emerging technology, and now it's basically, you know, your go-to for a lot of businesses. It's just, you go to the cloud. You don't even think about doing anything else. So the difference, the first thing is, my path was through having the ability to, all right, let's just wait for these cars to pass and I'm going to run over. Anyway, as I was saying, when yeah, my path is a path. It's a valid path, and everybody else has a different path. Cloud is different today than it was back then, right? If I had the ability to learn from the internet like I do now, I would have probably been in cloud in half of the time that it took me. Number two, learning, right? Having the ability to learn technologies, having the ability to you know, get to a point where you're comfortable about some technology and you can explain it to somebody else. That's where I would say, that's where most of my success lies in, right? It's what I do right now, being a cloud instructor and consultant. It's a continuously it's a process where you continuously evolve your knowledge, right? You continuously learn, you continuously have to upgrade your knowledge. The third lesson is, lesson number 3 is, if you're into computing, if you're into any kind of hobby computing, gaming, if you're into any kind of like technology, you know, there definitely is a path to a job in there, because just having that affinity for technology, having the desire to learn about technology can put you on a nice career path, right? So what I would say is, if you're a pure beginner, right, if you have no experience in computing, zero, if you have the desire to be in cloud computing, then your path is going to take some time, right? Because first you're going to have to learn about computing. You're going to have to learn about how computers work. I would say this is like something that a lot of people skip when they start doing, you know, things like operating system management or development, but they don't really know how the computing platform works. So how the CPU works, how it uses memory, how it uses disk. If you know those things, so if you have a basic understanding of those things, you will have a much better experience in understanding why things are done the way they are in software, and why things are done in the way they are in the operating systems, and why operating systems possibly don't even matter anymore when we get into cloud native. So a good underlying basis of computing, having the ability to differentiate input and output, what is compute, what is storage, what is networking, and how they you know, interact with each other. Those are your complete basics, right? Then you're going to have to learn, right now you're going to have to either learn a programming language that can interact with the hardware, or you're going to have to learn about operating systems, so one or more operating systems. Windows is not that difficult to learn. When you get down into the nitty-gritty of Active Directory and SQL and SharePoint, then it gets complicated. It gets a whole lot more complicated. But basic Windows management is not that difficult to pick up. Linux is something that will be very valuable to you, because the way Linux is designed is everything is a file in Linux. There is no other concept. Everything is a file, and because everything is a file, basically what you do is you start up a process from a file, right? You have a file that's got the binary for the process, you got a file that's got the configuration, and then the binary is read and the configuration is read, and that's put into memory, and it works, right? It produces the result that you want to have. Now the same thing is with device files. They're used a little bit differently. They're not loaded into memory. With device files, basically you have direct access to that device through that file path, right? So because everything is a file, security is simplified. You just do file-based security, which is great, right? You can really make secure platforms, and you know, this is a super simplified explanation of Linux. Don't go crazy in the comments about this. So yeah, basics of computing, operating system, or something like Python or Java or something like that, like a real programming language, or not a real, like a high-level programming language, a modular programming language where you can use libraries. And well, I'm digging myself into a hole, right? So yeah, any kind of programming language that will allow you to essentially interact with an operating system and perform, you know, and those are not mutually exclusive. Having the understanding of operating systems and having the ability to write some programming language, this is not mutually exclusive. This is possibly a very good idea, right? It can be very, very beneficial to you if you have both of those. It wouldn't be, it's not bad. And then on top of that, you start learning about cloud. You start learning about concepts that are familiar to you. If you're a developer, if you've picked up programming languages, then you're going to want to start using the SDKs, right? I mean, you're going to have the basics of networking, the basics of compute, the basics of storage down to be able to use those services, because you are going to be interacting with storage, with networking, with compute services. And then of course, if you've gone the operating system path, then you're going to start spinning up virtual machines, then you're going to go into containers, then you're going to configure networks for them. Again, whatever is familiar to you as a technology. So that's how you get started, in a nutshell, right? First, basics of computing. Second, go on a path, like for example, learn a programming language, learn an operating system. And then number 3, start using the cloud. And for cloud, it's all publicly documented, right? That's where I'm gonna end this video, because it's been fun and this is the end of the road and I need to start heading back. And yeah, thank you very much for watching. I hope you found this topic interesting, and if you do find my videos interesting, I would like to ask you to consider subscribing. Thank you. Bye.